Hello everybody and welcome back. Today we are going to work on another linked list problem where we need to eliminate elements of the linked list depending on the node value of each one. Alright, cool. Without further ado, let's move to the board. So here we are, problem number 203, remove linked list elements. And the question, guys, states, given the head of a linked list, aka that bit, and an integer val, so that is going to be the value of each node, the value of the corresponding node. We need to remove all the nodes of the linked list that has that property. And after that, we need to return the new head of the linked list. Okay, so what I'm going to do is I'm going to work with a classic two pointers approach, and I'm going to use two pointers, the current pointer and the previous pointer. Alright, so now, and of course we need to loop through the entire linked list, and if we find a node which value is equal to the integer val, we need to eliminate it. Of course we cannot delete that node from the linked list, so what we need to do is to actually erase the pointer to it. Sweet, now that we are clear, I need to state that we have two different cases here, guys. The first case is where the node which has that property is the head of the linked list for that iteration, and the other case is when where the head node doesn't fulfill that equation. Okay, so if the head of the linked list fulfills that equation, then what we are going to do is we are going to move the head of the linked list one position to the right. So something like head is equal to head.next. Otherwise, we need to break the connection. So let's assume now that we have the number 6, which is here and here, as the integer val. So what we need to do is, first iteration, the value of the node is 1, so we just need to move one position to the right both pointers. So that's the p new and that's the p new and that's the current new. So current new has the value of 2, that's not equal to 6. So we continue moving our pointers one position to the right, and now the current new has the value of 6. So we need to eliminate that node. And as I said, we cannot delete that. So what we need to do is we need to eliminate this connection, and from the previous node we need to, instead of pointing to the current, we need to point to the current.next. So this node here. And the current will going to be moved here. And the previous node is not going to change the position. So at the next iteration we have previous here and we've got current here. Okay, current is not equal to 4, then one position to the right, previous here, current here, current is not equal to 6, so one position to the right, current here, and previous here. And now, as you can see, this node has the value of 6, so we need to eliminate that, so we don't have any next node, so the only thing that we need to do is actually point the previous.next to the current.next, and the current.next is the null, so that pointer will point like that, and that node is not anymore part of the linked list. Sweet. Okay, so let's move to the LeetCode website and let's see how we are going to do that algorithmically. As I said earlier, we are going to work with the two pointers approach, so what I'm going to do is I'm going to define the previous pointer, which is going to point to null initially, and the current pointer, which is going to point to the head of the linked list. So we need to create a while loop here in order to loop over the linked list, and I'm going to say just while car is actually the same thing with that. So the condition that will bind that while loop is going to be that current is not equal to null. That means that we are going to loop one position to the right every time until current reaches the null. For simplicity, let's keep it like that. And here I'm going to check whether the car.val is equal to the val. So if we have that condition, and we can have it, as we said, in two cases. Firstly, is going to be if we have a previous node, and if we have a previous node, that means that the current node is not the head of the linked list. So we just need to break that bit, and we need to point from the so the previous.next needs to point to the previous.next.next, so the current.next. And we are going to do it like that. And yeah, I forgot to add if previous here. Sweet. And here is the situation where we don't have a previous pointer, and that means that the current pointer is actually the head of the linked list. Okay. Proper yep. And if that condition is not fulfilled, then we need to move the previous to the current, and that is going to be in an else. And for every time we need to move our pointer one position to the right, and when that while loop ends, we need to return the head of the linked list, the new head of the linked list, sorry. Let's run this code. Sweet. And if we submit that, that's perfect, actually 95%. Okay. That's it for today, guys. I hope you enjoyed that video. If you like that, give that a thumbs up, share it with your friends, and if you haven't subscribed to my channel, please do that. Support this channel. Catch you in the next one. Cheers!